Hi everyone, welcome back. In this week's videos, we're going to introduce our next building blocks, functions. So far, just to recap, right, we've covered variables, allow us to store information in programs. We've covered conditionals, which allow us to have choice and branching. We have loops, who allow us to take chunks of our code and just let the computer repeat it over and over. Last week, we talked about arrays, which are basically an expansion of variables, right? That allows us to create multiple variables at once, and combined with loops, arrays are going to be very powerful moving forward. Today, the building blocks we introduce, functions, are going to be focused a little bit more about on how do we structure our code. Our programs are going to start to get a little bit longer as we make things more complex. And with functions, we're going to be able to break our code down into some smaller, more manageable units. We're already familiar with functions because we've kind of used them since the beginning. On the screen here, I went ahead and I created a new sketch, already put in window width, window height, and a black background. And we've been using the draw and setup function all along. We also talked about adding event functions. And whenever we program in p5.js, we also rely on the functions that come with the p5.js library. Those are commands like background. So these functions were written by somebody else, and we're just leveraging them. So today we're going to explore the syntax for how do we make our own functions, right? Because we can create as many functions as we want. We can invent our own. If something doesn't exist that we need our program to do, we can just make that function. So let's start with a little example. In this first lesson, we'll cover just the basic concepts behind functions and their syntax. In the next example this week, we'll go a little bit further. We're going to connect this back to arrays, objects, and talk about how we can use functions more as a way to create behaviors. Okay. All right. So in order to talk about functions, we need kind of something to work with here. So we'll start off this sketch just by writing a little bit of code that's going to draw something simple. Let's say we'll draw like a flower, kind of like a daisy. Okay. So maybe we'll translate the origin here by width over 2 and height over 2, move it to the center of our screen. Let's set a white fill for our petals, perhaps, and let's write a for loop here. So we're going to draw five petals. Okay. So we set up a for loop. It's going to count with I. As long as I is less than 5, it's going to repeat, and it's going to increase I in steps of 1. Okay. Now, at each step of the loop, I'm going to use translate and rotate to position my petals around a circle. So we're going to use push and pop to make sure those translates and rotates don't end up stacking with each other. All right, so let's put down an ellipse first. Actually, instead of a circle, we're going to use ellipse because I want to get that elliptical shape. We're going to draw an ellipse at 0, 0, and let's say we're going to make it 80 by 50. Okay. All right, let's hit play. So this is what it looks like. We have our 5 ellipses, right? So if we put in some rotation in here, we could work in radians, but just for the sake of clarity, let's change the angle mode to degrees so that we can operate in the world of degrees. Right? It's more comfortable for a lot of students. And let's put in some rotation here. Okay? Now, how do we know what angle we need to be at each step of the for loop? Well, we could look at our counter. Right? We could say, let's make an angle. We're going to map the counter. So the counter goes from 0 to 4, okay? And we're going to map it to an angle between 0 and 360. Okay? And then we're going to use that as our angle. So let's see what that looks like. Okay, so now we can see we have our ellipses have been rotated, but they're all on top of each other because they all rotate around the same origin point, which is over here. So in addition to rotating them, we're also going to translate them in their respective direction. So after the rotate, let's put in a translate by, I don't know, let's say 50 and 0, kind of matching the height of the petal. Okay. Now, if you're paying attention, you may notice something interesting is happening here. When we used map before, right, we always used the actual range of the variable as the boundaries for map. And here we have a loop that repeats 5 times, which means the counter I only goes 0, 1, 2, 3, 4. So that makes sense. But we are mapping to a range that goes from 0 to 360 degrees, which means the first petal will be at 0 degree, right? The second petal will be mapped from here, and then the last one, right? The last one, when I equals 4, will end up back at 360 degree, which is a full circle. So the last one ends up right on top of the first one. So this is not what we want. We actually want to be able to map the rotation such that the last petal is not quite back to where the first one started. We want to get this even spread. So we're going to trick map a little bit here, and we're going to lie, and we're going to say, you know what, I is going to go from 0 to 5. Okay, we're going to pretend we have 6 petals, and we're just not going to draw the last one. Okay? And now that looks like this, a little bit more what we expected. So now we are seeing 5 petals, or if we put in 6, we are going to see 6 petals. So just a little trick sometimes, thinking about kind of being aware of the boundaries of map. Sometimes it helps to cheat a little bit and just tell map, you know, we're going to go up to 5, but in actuality, the variables is going to end at 4. So we're never quite going to reach this 360 boundary. Okay. And then let's put a circle in the center just to complete the shape here. We're going to put a little circle in the center, and here we go. We have a little bit of code here that's drawing a pattern, a flower. Just gives us something to work with to talk about functions. Okay, so we kind of already know the syntax, right? How do we create a function? Well, we use the keyword function. We put the name of the function, parentheses. Oops, don't drag this, and then we have the open and close curly brackets. So let's go ahead and we're going to create our own function. And we're going to take this code that knows how to draw a flower, and we're going to put it into a separate function that we're going to make up. Okay? So I'm going to create a function down here, and I'm going to give it a name. I'm going to call it flower. So there's no function called flower in p5.js, so this name is fair game. Just like with variables, the naming of your functions, right, follow the same naming conventions. You can use whatever name is legal and doesn't already exist in the library. If you do, you're going to kind of overwrite an existing function, and you don't want to do that. So let's call it flower. We're going to open and close curly brackets, and now this section of code becomes our flower function. So let's take this code we have over here. I'm going to cut it and paste it below into my flower function. And let's tidy up here so that the indents are correct. So now we can see we have 3 functions in the program. And like I did in other examples, just to make it clear where functions end and begin, I like to put a little line of comments here. Just visually makes it a bit easier for us to navigate. And if we hit play, right, not surprisingly, this flower disappears. That's because we've taken the code that used to be into draw, we've moved it into this flower function. So now we've created a command, but unless we call that function, the code that we parked in there is not going to run. So now we can go back into draw, and instead of the code we had before, all we have to do now is we can say flower. And that's going to cause the code to jump into the flower function, run the code that we placed in there, and then go back here when it's finished to continue whatever we put afterwards in draw. Okay. All right. So at kind of the first layer, functions are helpful because they allow us to start to take our code, break it down into smaller components, right? As our programs get bigger, you know, the draw function starts to get long, and it starts to become difficult to keep track of. So now with functions, we can take code that we've written that does kind of one cohesive thing and then put it into its own block. And we can also give it a name, which again, names are helpful because just like with variables, if we start to represent abstract looking pieces of code, right? Unless you're very used to this, you may not stare at this code here and say, oh yeah, that's drawing a flower. But if it's in a flower function, then that becomes a little bit more obvious what the code inside is doing. So names allow us to get labels, and in turn, our code becomes easier to manage. Now, if that's going to face level 1 of functions, we can start to create sections of our code. But one thing that's happening here is that this flower function is not very helpful, not very useful by itself, because it can only ever draw this specific flower in this specific location at this particular size. Okay? So more often than not, when you write a function, you're also going to provide some entry points to customize how the function is going to behave, so that you can write code that you can reuse multiple times, right? Or even if you use it once, that you can pass in different parameters, and these parameters will get moved into the function, and they will allow you to change how the function behaves. Even though the code itself will be fixed, the values, the numbers that we use inside, those are all fair game to be modified by a parameter. Okay? So for example, let's start with perhaps the most obvious, right? Maybe the location where we draw this flower. This is something that we might want to be able to tell the flower function, like where to draw yourself, in the same way that ellipse and circle, right, take a coordinate. I think that's probably something useful we could do. So let's add two parameters to our flower function. We're going to add x and y. Okay? So the parameters to the function are much like variables. Okay? They're entry points into the function where we'll be able to provide values over here. Let's say we put in mouse x, mouse y. We'll be able to put in values when we call the function, and then these numbers will get passed onto the function through these parameters. So when we call flower here, mouse x, the value of mouse x will become x in the function, and the value of mouse y will become y. And then we can use these as we would use variables normally. So here we might want to translate by x and y instead of always width over 2, height over 2. Okay? And now we can have this flower following the cursor. Now let's say we wanted to draw a second one. We could, right? Because we've made this into a function. If we want to use that code again, we can just call the function as many times as we want. Maybe we'll put one back in the center of the window. Okay? Now we have to be careful because we have to remember when we call functions, right? We simply just replace the function call with the code that's inside. And here I've began my function with a translate. So let's see what happens. So now this first one is in the correct location, but the one that's supposed to follow my mouse is offset now. That's because the origin is being translated. Okay, so the origin is no longer 0, 0, it's actually on the center. So everything has that offset moving forward. So just like we use push and pop inside this for loop, we're also going to go the extra step in our flower function. Okay, just to be safe, we're going to put push at the beginning, save the origin, save the rotation state, save everything, and then at the end, put a pop. Okay, so that we can put things back the way we found them before the function started. This way, if we call flower multiple times, the translates and the rotates and other things that happen inside the functions are not going to spill over to the rest of what we're trying to do in the program. Okay. Cool. So we can add parameters to functions so that they can be a little bit more kind of customizable, right? They can do something that we've programmed, but if there's opportunities to expose some of these numbers, right, we can expose them through parameters so that we have that extra flexibility when it comes time to using our function. So we've made the coordinate into a parameter. A bunch of other things we could make into parameters as well. Okay? For example, the number of petals, right? Maybe we want to vary. We want to have one flower that has 5, one that has maybe like 7 petals or whatever. So we could say, let's add a parameter that's going to allow us to do that. We're going to call it number of petals. Okay, so that's quite a long name, but sometimes it helps to make your variable names very explicit so that there's no confusion as to what they're actually going to do. So I choose to use this wording here. You could call it whatever you want. You know, we could have made it shorter like this. I'm just going to go the route of making it super spelled out. So let's go number of petals, and instead of 5 in my for loop here, we're going to use the number of petals. And instead of 5 in the map function, we're going to use the number of petals. Now I have an extra comma here. Now it's important to note, if I hit play here, I'm going to get some errors. Okay, well actually it doesn't even give me an error, it just assumes 0 here, interestingly, but that means this for loop never happened, right? So if we said this parameter now exists and we're going to use it inside our function, we have to follow our own rules that we set out for ourselves, and when we call the function we have to remember, okay, now we need to pass this extra parameter. So perhaps the one in the center will have 7 and the one following the mouse will have 5. Okay, so now we have that extra flexibility that we can do that. Okay? Let's see, what else could we want to do? Let's make the size of this flower a parameter as well. Okay, so let's maybe we'll call that one size. Okay, so the size, we can think about how we would approach this. Okay, so the size, it's really kind of like a radius, not really, sort of. We could say, okay, maybe the number 80, which is the width of a petal, is what's going to determine the size. Okay, So in our design, in our original design here, we have this ratio happening. We're using the number 50 for the translate, for the height of the petal, and also for the size of the, what is it called? The pistil, the center, okay, of the petal, of the flower. So the ratio here that we kind of came up with is we have 80 to 50, right? So if we wanted to generalize this, let's say we replace 80 with size, okay? Then how do we come up with the number 50 from where we were before? Well, the ratio was one of 5 to 8, right? So 5/8 was the ratio that we used to have, right? If we had 80 to 50, right, we can simplify. So we could keep that in. We could multiply. We could multiply by size by 5/8, or we could go like, what's 5/8? It's 0.625. Okay, so why don't we use that ratio? We're going to say size times 0.625. Okay, so 5/8 is 0.625. In case later on we come back to this code and we're like, why did I do this weird multiplication here? This is just so we get the same ratio of petal width to petal height, okay, that we had in our original design. And now we have one number that we can tweak that will control this. So again, let's say maybe we'll make the middle one a little larger and the floating one will remain at 80 like we had before. Okay. Cool. So now we've added a parameter where we can control, in addition to the position, the number of petals, we can also control the size of this pattern we're drawing. Good. And just for fun, let's put another parameter as well. We're going to add the option to set maybe the color of the petals. Okay, so let's say petal color, okay? And then we can use that variable here instead of a white fill, and maybe the centers will always be yellow. Okay, so that maybe now we can have this one be white and this one be pink. Okay. Cool. So we could go on and on. Of course, in this simple function here, there's not too much more we may want to make kind of adjustable, tweakable. But the idea is that with a function, we can now design our own commands, right? Our own reusable chunks of code. And through parameters, we open up some opportunities to provide, when we call this code, right? Here's plug in some values so that this function can use these numbers to do its job and do the same algorithm, the same recipe we put in, just with different numbers plugged in. And then that becomes very useful because let's say, for example, let's say we combine this with some randomness and we combine this with a loop, right? Now that we've written this as a command, we can very quickly take this idea. We say, okay, we figured out how to draw a flower. We've encapsulated that into this little reusable command. Now we can use it to build more interesting things. Like let's say we wanted to fill the screen with flower, create this random texture or something like this. We could say, all right, let's oops, I'm just gonna comment this out. By the way, when I select blocks and comment and uncomment, I'm doing control and /, just a little aside. So let's say we write a for loop here. We're gonna draw a for loop. We're gonna write a for loop that repeats 100 times, and then inside this for loop here, we're gonna draw a flower, and let's just randomize the height, the width, randomize the number of petals, maybe between 5 and 8, randomize the size between, I don't know, 40 and 80, and let's start with just white for now for the petals. I'm going to move my window here a little bit more, and that's going to look a little insane if I hit play because these will be random every time, so we're going to turn off, pause the draw function here by calling no loop. And now all of a sudden we've taken, we've given ourselves more flexibility, more power to program more complex things by creating these reusable blocks, right? And this is something we could use in future programs as well. Let's say we needed a program that needed this particular design. We could just bring in that function into a different program and then reuse it. All right. Just to make it a little bit more interesting too, let's create more than 100. Go to 200. I'm trying to get the screen filled a little bit more. We'll get some smaller ones. Let's go 300. Why not? We can. Maybe we'll vary the will vary the colors as well, right? So this is something I think we've done in a previous video, but let's make a little palette. We'll make a palette, and this palette is going to be an array that's going to contain a bunch of colors. Let's say white, pink, red, orange, and light purple. No, purple. I'm looking for some pastel colors. What about, okay, kind of like a light blue. So now I have 5 colors, and instead of putting in white here, just I'm going to run out of space. Let's make a variable. I'm going to call it C. When you have an array, you can pick something at random from that array just by passing it to the random function, right? So we can say palette is our bag of colors. We're going to pull one at random from the bag, put it into C, and then we're going to replace white with C, just to mix it up a little bit. Okay, so that's nice. And let's here we go. Now we're almost filling the entire screen with flowers. Okay, so to recap, right? First we had a little program that was doing something interesting. We used the function syntax to take that section of code that we had developed that essentially knew how to draw a flower, and we've packaged it up as a function, as a reusable block of code. And this idea that we can create our own functions is going to become really important moving forwards, because the P5 library, right, and JavaScript in general only can provide so many predefined functions. So in programs that you're going to want to write for yourself, you're going to be kind of the architect of that program eventually, and you'll have to get to a point where you create your own building blocks to build with. And this is what functions will allow us to do. And by putting code inside a function, not only do we create reusable building blocks that we can call upon with different values here and just slightly change how they behave, but also it allows us to really simplify our thinking, simplify our main program. Now our draw function, instead of having all of this code in it, simply says repeat 300 times, pick a random color, and then draw a random flower. The end. Okay, so this becomes very self-explanatory. So by dividing and conquering, putting our code into different functions, we are essentially simplifying our main program, and it allows us to build on that foundation to create more complex things eventually. All right, let's leave it at that for this first function example. In the next video, we're going to do one more example of functions, and this time we're going to look at functions more from a behavior perspective. So I'll see you in the next one.